Hello everyone and welcome back. In this video, we will take a closer look at SUOTA software update over the air for the DA14592 family of Bluetooth Low Energy SoCs. But before we begin, let's take a look at the DA14592 family. The details about SUOTA can be found in the DA14592 Software Platform Reference Manual from here. And on that page, scroll down to the design and development part. Here you can find the SDK, this one, which you will need to try SUOTA with the provided example projects. So what is SUOTA? It's a mechanism that allows you to update firmware on devices wirelessly over Bluetooth without physically connecting to the device. This is extremely useful in the field where devices may be deployed and inaccessible. There are two main types of SUOTA. Dual bank SUOTA, also called symmetric SUOTA. Two equal in size image banks are used. One is the active image that is executed and the one is the image that is updated. Application images are similar in functionality, but they expose the SUOTA service and are capable to perform the software update. The dual bank can be done in two ways. First one, using a mobile device like a smartphone app to push firmware updates, and the second one is using two DA14592X devices where one acts as the updater and the second one receives the update. And the other type is asymmetric SUOTA. The dual bank flow is most commonly used because it allows the device to maintain one valid firmware image while the new one is being written to the alternate bank. After the update, the device switches over to the new firmware safely on reboot. Now let's talk about the SUOTA service itself. The service exposes the several GAT characteristics that control the update process. And here's a simplified characteristic table of most commonly used characteristics. And the process goes like, first we discover the SUOTA service on remote site and then enable notifications from status characteristic. Then issue the start command from spot image SPI flash command to begin the update, and then set patch length to control notification frequency. This kind of flow control could be used to avoid flooding the SUOTA enabled device with too much image data. When the whole image has been sent, the GAT client should use the spot AR image end command to indicate this to the SUOTA service. Finally, the GAT client could use a spot AR underscore reboot command to force the device reboot. The final verification and activation of the new image is performed by the ROM bootloader on the next reboot. Keep in mind that during the SUOTA, only one device should be connected to avoid conflicts. For more details, check out the section 5.2.2 in the software reference manual. Now let's visualize the dual bank SUOTA flow. After production, this is the first image. When you push a new firmware image, it is written to the inactive bank, which is the image 2. Once the transfer is completed and finalized, the device reboots. After reboot, the device switches its active firmware image address to the newly updated bank. Now we will build the PXP reporter application, which starts advertising automatically once the application starts, and the advertisement contains proximity reporter profile information and SUOTA service information. Along with compiling this app, we will create a SUOTA image. A SUOTA image is a binary file with a proper header that can be sent to a target device from an Android or iOS device. So let's start. Open eSecure Studio. Import the required projects. From here, import PXP reporter project and Python scripts. Select toolchain version 7. Select your target device. In my case, it is DA14592. As the first step, we will erase the existing memory using the erase eFlash script. Select the required options and let the script execute. So the first memory is erased, and now we will build the program. Build the PXP Reporter app using the debug build with SUOTA support. Here the application is compiled. Along with the binary, a SUOTA image would be created. Here we have built this target. So under this we can see PXP Reporter image. This image is built from the Python scripts that we imported. And now let's move on to performing the SUOTA update. First of all, flash the app to the device, which is DA14592. The application is successfully flashed onto the device. Press the K2 button on the DK daughter board. The PXP Reporter application should start running. Now download the Renaissance SUOTA application from Google Play Store or Apple App Store. We need to copy this PXP Reporter image to an Android phone or tablet or to an iOS device and place it into the SUOTA folder. So connect your phone to the host PC, which is the laptop in my case. Go to the internal storage. On the Android, it is located at the root directory of the internal storage drive. So here we can find our SUOTA directory, and we will copy the PXP Reporter image to this directory. Now we can disconnect our phone from the PC. Here is the app that we downloaded. Now launch the Renaissance SUOTA application on the Android phone and select the DA1459 device that you want to update. Select the update device. Select the appropriate image file. Then there we have block size for copying the image, and the image bank where the image will be loaded. It is selected to be written in the oldest bank, which is the inactive bank. Then select the interface type used to write the external memory where the firmware will be stored, and map the GPIO pins for MISO, MOSI, CS and clock to match your board. Once everything is set, just press send to device to start the firmware update. Wait until the process is completed. When the image is uploaded, a Renaissance box will pop up for a device reboot. Select OK and press close to return to the main menu. And that's it. We have successfully sent a software update over the air. And in the next video, we will see how to perform an asymmetric update. So stay tuned for the next video. Thanks.